So we are in Module 5, Chapter 8. This is the final chapter of this module. We are doing properties of addition. So we use properties of addition. See that they're listed right here. We have the commutative, associative property. So I can use these two pieces of information, the two properties of addition, to help me add fractions with unequal denominators. So if you look, right, remember my commutative doesn't have parentheses. It just means that the order does not change. Do you see that? My order does not change. It doesn't matter. My answer, my sum will still be the same. Okay. And then my associative, it changes my groupings. Remember, my groupings are anything in parentheses, brackets, whatever it is. Groupings are put together, right? They're separated and they're put together using parentheses, brackets, braces. Okay. What does it say right there? I need to remember to do what first? Parentheses go first. Think about PEMDAS, right? Remember PEMDAS? We haven't done it in a while, but it's PEMDAS. I taught it as PEMDAS. Oh yeah, no, you're right. GEMDAS. I know what I'm saying. GEMDAS or PEMDAS, whatever floats your boat, whatever you understand better. Whatever it is, it's parentheses or groupings first, okay? Now let's look at this problem here, okay? So Jane and her family are driving to Big Lagoon State Park. On the first day, they travel 1/3 of the total distance. On the second day, they travel 1/3 of the total distance in the morning and then 1/6 of the total distance in the afternoon. How much of the total distance has Jane's family driven by the end of the second day? So if you see here, it says to use the associative property. So they wrote it out just like we had before, right? Right? They said 1/3 and then these two on the second day. My first day is not in parentheses, but my second day is in parentheses. So what do you think I might do to make this easier to add up? What do you think I might do to make it easier to add up? Remember, the associative property means I can group them differently, but I'm still going to get the same sum. Lexi. Parentheses, 1/3 plus 1/5 plus 2. And without parentheses, so I'm going to put the common denominators, the like denominators, in my parentheses because now I can just add them together. I don't have to find the common denominator yet, all right? Because I can add what's in my parentheses. So 1/3 plus 1/3 is what? 1/3 plus 1/3. Bryce. 2/3 because I add just my numerators and my denominator stays the same. So now I'm left with 2/3 plus 1/6. But now I have to do something. What do I have to do? What have I been doing? All of this module. What do I have to do? Somebody tell me. Grayson. Reduce. Not reduce. That's at the end. Peyton. Rename. Right? So I have to change my denominator to be an equivalent and equal fraction. So, what do you think the common denominator is here? Joseph, what's my common denominator? 6. So I'm going to come over here and I'm going to change 2/3 to have the denominator of 6. What do I multiply times 3 to get to 6, y'all? 2. So I do the same thing to my numerator. 2 times 2 is 4. 4/6 plus 1/6. I can do that now. What do I get? 4 plus 1 is 5. And my denominator stays the same, so it's 5/6. So Jane's family has driven 5/6 of the total distance by the end of the second day. So why is grouping the fractions differently making it easier to find my sum? Why did this make it easier? What did this do for me? What did this change? Payson. I mean, kind of. Yes, Peyton. Right. It makes it easier because now I have the same denominator. When I have, when I have the same denominator, I can add them, right? It makes it easier. So because I know the associative property means I can order my groupings how I need to, and it's still going to give me the same sum. This makes my adding easier. So then I just have to come, and now I only have to do the denominator change once, not to all three, right? So moving on. Oh my goodness. I'm going to have to use the commutative and the associative property here. Okay? It looks scary, but I promise it's not. Okay? So, what do you know about my numbers that I'm adding? This one. What do you notice about what I'm adding here? I need to find the ones with like denominators. Which two have like denominators? You can say like first, second, third in the row. Okay, so first and third, right? This one right here and this one right here. So I'm going to put those two in my parentheses. And then the other one, my second one here, that's going to go on the outside. Okay? So I use the commutative property to put my same denominators in my parentheses. Then I'm going to use the associative property to group my fractions. Oh, wait, sorry. I'm going to use it and I'm going to put it here. I'm just going to do what I did here, but move it, okay? 1 2/3, 2 5/8, and then 1 1/8. So now I'm going to use mental math to add my fractions with like denominators. So okay, so look, right here, I have like denominators, right? So I'm going to add them. What is my numerator here? 5 plus 1. 6/8, right? And then what about my whole numbers? 2 plus 1. 3. And then I keep the other one the same, right? Because I'm just doing the mental math here. No. My thought was maybe, so I need to find the equal denominators, right? What do you think my common denominator will be? Think about 3 and 8. What is the least common denominator for 3 and 8? What's the least common denominator for 3 and 8? Least common denominator, 3 and 8. Joseph, 24. So my denominators are going to have 24. And what gets me to 24? I have to multiply them by each other, right? I have to multiply 3 times 8 to get 24 and 8 times 3, right? So I'm going to take that 2/3 and I'm going to take that 6/8 and I'm going to multiply them. 3 times 8 gives me 24 So that means I need to multiply 2 times 8, which gives me what? 2 times 8 is 16. Hey, and then what about down here? To get to 24, I do the opposite, right? I do 8 times. So 6 times 3 is 18. So I put 16 right here, put 18 right there, and then I keep my whole numbers the same. So now I'm going to add them. What is it going to be over 24? 16 plus 18. 16 plus 18. 16 plus 18. Lane, we agree?
Yes.
34? 1 plus 3. 4. Lexi, what did you realize that was wrong? Okay, so first of all, I want to look at this, how I got from here to here, all right? So, I know that 34 over 24 is an improper fraction, right? So, I have to subtract 34 minus 24 to get my remainder, so what's left over. And then that whole, right, I have to add to my whole here. So, I take 24 away, I add it to my 5, right? And then now I have 10 over 24. However, I can still simplify that by dividing. What can I divide both of those two numbers by? Joseph. 2. I'm going to divide them by 2, which gives me 5 over what? Can I reduce that anymore? That is my final answer. 5 and 5, 12. So, let's do the try this. So remember, subtraction is not commutative nor associative. When I subtract, I perform the operations in parentheses first, then subtract from left to right. Remember, this is like what? What is this called? Oh. Remember, what is it called though? What is the title of that? The Peyton. It's the order of operations. So I'm using the order of operations here. So, guess what? As it all ties together, ladies and gentlemen, this will not go away. Order of operations is a fact of life. So, here, right, I'm just going left to right. But I have to do something to a specific number. What is it? Which one do I have to change something? Kason. Okay, so what is the common denominator? 8, right? So I'm going to change 1/2 to have a denominator of 8. What is that? What do I do to get to there? What do I do? Multiply by 4. It's 4/8, right? So 7/8 minus 4/8. What do I get? 7 minus 4 is 3. 3/8, then minus 1/8. Gives me what? 2/8. But can I leave it like that? I have to simplify it. How do I simplify it? Girl, you need to write. How do I simplify? I divide it by what, ladies and gentlemen? 2. And my final answer is 1/4. So on letter B, right? On letter B, I already know what my 1/2 is equivalent to, right? It's equivalent to what? 4/8. So 7/8 minus 4/8 comes first, right? So what was that? I got 3/8, right? And then 3/8 minus 1/8 is 2/8. And I get the same thing. I have to simplify it and get 1/4. Is it important the order? Yeah. Because I can't do 4/8 minus 1/8 first. I have to do it in the correct order that's given to me, starting with the parentheses. Okay. Now this one right here, I'm changing that one to 4/8 too because I already know that information. So 4/8 minus 1/8 is what? 3/8. Right, so then I get 7 minus 3 is 7 minus 3 is 4. Oh, well, was that the same as what I did up here? No, it's not. Now I can divide it by what? Not 2, 4. So then I get 1/2. So knowing that, how do I know that this is not associative? Remember, do I get the same answer every time? No, I don't. Okay? The order matters with subtraction. The order matters. I can't do it out of order because I will not get the same answer. Up here, I can add them any which way I want to. And I'll get the same sum every single time. But if I change the order of when I subtract, I will not get the same answer. So, as an explanation here, I can say something like, I don't get the same answer for parts B and C. Because if it was an associative property, the parentheses would give me the same result. That's what I want us to understand, is that for B and C, I don't get the same answer. I don't get the same answer. If subtraction was associative, my groupings could change and get the same answer. So what I'm saying here, you understand what I'm saying? The order does not matter of which way I add. When I change the order of how I subtract, it changes my answer. Therefore, the associative property does not work. It does not apply to subtraction. Because if it were the case, then this would both be 1/4 or 1/2. Do you understand that concept that we won't get the same answer with subtraction, but with addition, it will be the same. Okay. So I'm gonna do some example problems. I'm gonna do so I'm gonna use the properties that I've just been talking about in order to solve. Okay, let's do 2. Remember, if I use My associative property, I put the numbers with the same denominator together in a grouping. So which two, first, second, or third, which two can I put together? Or second or third? Pick two. Which two can I group together? Which two can I group together? Which ones have the same denominator, y'all? Thank you, Jason. Okay. So I'm going to group 5/12 plus 5/12 because that makes my adding easier. Because now I just add those two together. 5 plus 5 is what? 10. 10 over 12. And then I'm going to add that to 3/4. So now I have to change 3/4 to the common denominator, right? So 3/4. What is the common denominator between 12 and 4? We use this one quite a bit. What is the common denominator of 12 and 4? It's one of those two numbers. Presley. Not 3. What's the number that multiplies 2 with 3? Lexi. 12. 12 is the common denominator. You multiply 4 times 3. I knew what you were trying to say. Okay. So, I multiply both my denominator and my numerator by 3 to get 12, right? 3 times 3 is? 9. 9. So now I have 9 plus 10. What is that? 19/12. Oh. But can I leave it like that? 19/12. So I need to do what? Right. I need to rename it. So 19 minus 12 is what? 7. 7. So I have 1 whole and 7 twelfths. Can I reduce it any further? No. No. All good to go. Okay. So I'm going to do one with mixed numbers. So let's do 3. Okay. So what are the two that I need to combine together because they have like denominators? 8. 3 and 1/4 plus 1 and 3/4. And then I add the 2 and 5 6 on the side here. So what am I doing about 1 and 3? What am I going to add together to give me? What is 3 plus 1 going to give me? 4, which gives me 1 whole. So I have to add 1 whole to 3 plus 1. So 3 plus 1 plus 1. 5. So now I have 5 plus 2 and 5, 6. Oh, that's kind of nice now, isn't it? I don't have to change my denominator. What's my answer? What's my answer? 7 and 5, 6. 7 and 5, 6. Oh, that's so nice. I like that one. I didn't have to change anything. It was wonderful. So I'm going to do one more on this side over here. Says, let's do 5. Okay. So which two do I group together, y'all? Which two do I group together? Maddie.
You could, one inside, one side, and the,
1/5 and 2/5. And then I put the 1/2 on the outside of my parentheses. 1 plus 2 is what? 3. So 3/5 plus 1/2. What is my common denominator here? Lexi. I'm gonna rename. I'm gonna find a common denominator. Yeah. Renaming. I know we talked about renaming a lot yesterday. I should have probably. So, what am I doing? Because my common denominator is what? 10. Just like I've done before. We're not doing anything different. We're just adding some extra parentheses there. Okay. So 5 times 2 is 10. That means I multiply this by 2 as well, which is 3 times 2 is. And then I multiply 2 times 5. Yeah. And 1 times 5 is. 1 times 5 is? 5. 6 plus 5 is? Over 10, which means I need to do what? I can't leave it like that. Now I'm reading 1 times 10 is 1, right? So I have 1 whole and 1 10. So, why does grouping fractions make it easier to find the sum? Tell me again. Why does grouping the fractions differently make it easier to find the sum? Maddie.
Because there's a common denominator.
Denominator makes it so much easier and faster because I know it seems crazy to see 3, sometimes 4 fractions all at once, but if I group those common denominators, I make it quicker and easier and faster to get it taken care of, okay? And that is the end of the lesson.